So we left off on Monday talking about midpoint formulas and distance formulas and slope formulas and all that. Just want to do one quick example of midpoint and slope to remind us, and then we'll get moving on to new material. So for midpoint, you recall the midpoint between 2 points. If I have the points, my endpoint A is x1, y1, and my other endpoint, point B, is x2, y2. My midpoint, the x-coordinate is just the average of my other x-coordinates, x1 plus x2 divided by 2. And my y-coordinate is just the average of my other y-coordinates, y1 plus y2 over 2. So if I have that point, 3, negative 4 is point A, and the other endpoint B of 7, 8, my midpoint is going to be found, my x-coordinate is going to be found by averaging my x-coordinates. So 3 plus 7 divided by 2. 3 plus 7 is 10 divided by 2. 10 divided by 2 is 5. That's my x-coordinate. So my midpoint, the x-coordinate is 5. My y-coordinate is going to be found by averaging the y-coordinates in my point. So negative 4 plus 8 divided by 2. Well, negative 4 plus 8 is 4 divided by 2. 4 divided by 2 is 2. So the y-coordinate of my midpoint is 2. So that one's relatively simple. A little bit more difficult formula was that distance formula. The distance between 2 points, or the other way to think of it is the length of a line segment with those given endpoints. If I have points x1, y1, and x2, y2 again, that distance was the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I were given 2 points, 3, negative 2, and 8, 10, and I was asked to find the distance between them. Well, that distance is going to be the square root of, I'm going to label my points 1 and 2, just to make it a little simpler. x2 will be 0.2, the x-coordinate, that's 8, minus x1 was 0.1, the x-coordinate, which is 3 squared, plus parentheses y2 is 0.2, the y-coordinate is 10, minus y1, 0.1, the y-coordinate is negative 2. So I'm going to put that in parentheses so we know it's minus a negative. And then, of course, squared. So now it's just a matter of doing the math. Rather than doing it out by hand here, I am going to go ahead and just punch it in the calculator, because we can just do this all at once. I'm going to hit square root. Now, again, on some of your calculators, you have the square root key like mine, where the root appears and it puts the numbers inside of the root. Others, the root appears with a parentheses like that at the beginning of it. I'm just going to put that parenthesis in there so I can simulate your keystrokes. And of course, you wouldn't have the root over the top of it, but it'd be right in front of that first parenthesis. But anyway, so we're going to put in the parentheses now to enclose this here, this first parenthesis. 8 minus 3, close that parenthesis, x squared, plus, we're going to open the parenthesis for this one here. 10 minus, we don't have to put the negative 2 in a separate parenthesis here, because we're subtracting it, not multiplying by it or doing a power or anything. Close that parenthesis and squared. And then many of you will have to close the parentheses now to end the square root. So it comes out to be 13, which is exactly what we would have got doing it out by hand. So that distance is 13. So 13 units between those 2 points. Right here. Today we want to start looking at constructing equations. And we did this a little bit last week, but I want to do it now from other information. So to review kind of what we did last week, if I have a line on the graph that looks like this, to write the equation of that line, we know that that equation takes the form of y equals a slope, and we're going to label it m, times my variable of x, plus or minus b, which is what my y-intercept is going to be called. So now from this, I can find b really quick as my y-intercept of 2, so b is going to be 2. My slope, positive 2, my slope can be found by doing a rise and a run. So I've drawn a triangle here. This actually goes down 2, so my rise is negative 2, and it runs 3. So it gives me a slope, excuse me, of negative 2/3. So it's negative 2/3 times x plus 2 is my equation. Well, rather than having the graph in front of us, we're going to look at this. Find the equation of a line with slope of 3/4 and y-intercept of negative 1. Well, what that's saying is, remember, y equals mx plus b, where m is the slope and b is the y-intercept. So we just plug the numbers in. Y equals m, my slope is 3/4. So I put 3/4 in there, times x, plus b is my y-intercept of negative 1. So I'm actually going to take out the plus and put in just minus 1. So y equals 3/4 x minus 1. Usually not quite that simple. Usually they're not just going to come right out and say, here's your slope, here's your y-intercept. So a lot of times what they're going to do is like this. Find the equation of a line with slope of 1/4 and going through the point 8, 3. So we know it goes through that point 8, 3 at some point, and we know it has the slope of 1/4. So our basic equation, y equals mx plus b, we can put in the 1/4 for the slope, for m. So we know that's y equals 1/4 times x, but we don't yet know what b is, what that y-intercept is. So we have y equals 1/4 times x plus b yet. We need to know b. And to find b, we can use this point that the line goes through. If the line goes through that point must make this equation true. So we put those values in for x and y, and b has to make that equation true. So the point 8, 3. Which of those numbers goes in for the x? Eight goes in for the x. Very good. So it's 1/4 times 8. Which number goes in for the y? 3. Good. So we got 3 is equal to 1/4 times 8 plus b. So now the next thing we have to do here is order of operations. What is 1/4 times 8? One-fourth times 8 is 2. And then we subtract 2 to find b. So 1 equals b. So what that does is we bring that up here, combine it with this equation. Y equals 1/4 x. B is positive 1, so plus 1. Were they out for the day, or what's? Oh. Gotcha. Okay. Okay. Usually 3 or 4 at least in part 4. Okay. Thanks. All right, let's do another example similar to that. So again, we're going to find the equation of a line with slope. We're going to do a negative 3/2 and going through the point -4, 1. Okay, so again, we know that this takes the form y equals mx plus b. We know at this point that m, the slope, is negative 3/2. So y equals negative 3/2 times x. And we have to find b. So to find b here, which number goes in for y? Y is going to be 1. Very good. So this will be negative 3/2 times what number goes in for x? The negative 4. Good. I'm putting in parentheses just because it's a negative, so we don't look at that as minus 4. Plus b. So then we have to multiply there. Negative 3/2 times negative 4. Well, negative times a negative is a positive. 3/2 times 4 is 6. So 1 equals 6 plus b. We'll go ahead and subtract 6 to get negative 5 equals b. So again, we combine that with what we started up here. So y equals negative 3/2 times x. And then b is negative 5, so minus 5. Good morning and Hurley. It sounds like we had a locked door on you there.
Yeah.
Sorry about that. We're just writing equations from given information using the fact that we know y equals the slope times x plus b is the y-intercept.
Alright.
So like our next example would be find the equation of a line with, let's say, a slope of 2 and goes through the point, let's do 7, 8. So we know that equation, again, y equals slope times x plus b. We know that the slope, m, has to be 2. So y equals 2 times x plus b. So then we go ahead and we have to use this point for x and y, and that'll tell us what b has to be, because this point has to make the equation true. So what's going to go in for y here? 8 equals 2 times what goes in for x? 7. So 8 equals 2 times 7 plus b. We'll go ahead and multiply the 2 times 7. It's 14. And now to solve for b, we have to subtract the 14 to get b by itself. So we subtract 14. 8 minus 14 is a negative 6. So negative 6 equals b, or b equals a negative 6. So again, we'll use that along with this part here where we plugged in the slope. We're going to replace b with negative 6. So y equals 2x, and instead of plus b, we put in the negative 6. So that's not too bad. Our next step would be, what if I tell you that, ask you to find what is the equation of the line that goes through the points 3, 5, and 9, 11. Now this looks very different, but it really is not any different than what we were just doing, the last couple of examples. Because anytime we have 2 points, we know the slope. Because remember, the slope is y2 minus y1 over x2 minus x1. So I make these points 1 and point 2. What goes first up on top here? 11. Good. It's y2, so point 2, the y-coordinate is 11. Then minus 5. Good. y1 is 0.1, the y-coordinate, which would be 5. On bottom, what comes first? 9. x2, it's 0.2, the x-coordinate. Minus x1 would be 3. Good. So now we go ahead and subtract. What is 11 minus 5? 6. 9 minus 3 is 6. So we've got 6 over 6, or 1. This is a slope of 1. So now we know our equation has that form, y equals mx plus b. Well, we now know that slope is 1. So y equals, I could put in 1x, or just x plus b. And now it's just like we did before. I can use one of those points, or either one of them actually, to figure out b. And it doesn't matter which one. In fact, I'm going to do it both ways to show you that it doesn't matter which point. So let's do this one first, point 1. So that's saying y would be 5, and x would be 3. So 5 equals 3 plus b. That's a pretty simple one. All you have to do is subtract 3. You get 2 equals b, or b equals 2. If I had used the other point, the 9, 11, y would equal 11 when x is 9. Well, we solve that. We're going to subtract 9. Again, we get that 2 equals b. So either way, b has to be 2. So we combine that up here with this equation to get y equals x plus 2. So let's do another example or two of those. So again, find the equation of a line that goes through points negative 5, 1 and 10, 7. So again, our first step is going to be to find that slope. So the slope is going to be found. We're going to label these points 1 and point 2. So y2 is going to be 7 minus y1 is the 1. On bottom, what's x2? 10 minus x1 negative 5. So we'll go ahead. 7 minus 1 is 6. And then 10 minus a negative 5 is 15. We'll go ahead and reduce that. Both of those can be divided by what number? 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So we get a slope of 2/5. So now we go to write our equation. Y equals 2/5 x plus b. Now again, we can choose either point. It doesn't matter which. I'm going to choose the second one here because I don't want to work with the negative. Doesn't matter. I could use that one if I wanted to. So what number is going to go in for y? Y is going to be 7. 2/5 times x is going to be 10 plus b. So now we're going to have to multiply. 2/5 times 10 is 4. So 7 equals 4 plus b. And now we're going to solve for b. So we're going to subtract 4. We get 3 equals b. So again, we bring that back up to this equation. We replace b here with 3. So that's going to become y equals 2/5 x. And instead of plus b, b is a positive 3. So it's going to be plus 3. There's the equation of that line. So writing those equations is pretty simple. On Friday, we're going to come back and we're going to look at parallel and perpendicular lines and how that fits into writing equations of those lines with similar process to this. Now, there is a process that's a little bit simpler, not something we're going to be tested on in this course, but there is a form of a line. We've looked at 3 forms of lines so far. We've looked at standard form, in the standard form of a line, it's some number times x plus some number times y equals a constant, or it's often some number times x plus some number times y plus some constant equals 0. This is technically the formal standard form, but this is often called standard form as well. But technically standard form is equal to 0 on the other side. And we've talked about graphing form, or y-intercept form, or slope intercept form, I should say. Slope intercept form, which is what we've been using for graphing and what we were just finding up above. Y equals a slope times x plus y-intercept. Well, there is another form that is kind of useful in those situations, and it is called point slope form. And point slope form of an equation is if I have a line with slope equals m and through the point x1, y1, the equation is y minus y1 equals the slope times x minus x1. So if I am asking you what is the equation, find the equation of a line with slope of 3/4 and through the point, make this simple on ourselves here, through the point 8, 1. That point slope form, all I'm going to do is y minus y1 is going to be 1. So y minus 1 in parentheses equals my slope of 3/4 times in parentheses x minus x1 is going to be 8. So there's an equation. This is equivalent to the y, what we would do for the y-intercept, slope intercept. If I were doing slope intercept here, I would start out as y equals 3/4 x plus b, and I would use that point 8, 1, so 1 for y, 8 for x. So 3/4 times 8 is 6. And I would subtract 6 to get b by itself. So -5 equals b. So that's telling me if I replace this b here, the equation is, I'm going to write it down here so it's out of the way, y equals 3/4 x minus 5. That's the equation we get. Well, this one up here that we got, the point slope form, is equivalent to that. I've got y minus 1. I don't need those parentheses. 3/4, if I distribute here, 3/4 times x is 3/4 x. 3/4 times -8 is a -6. All I have to do to move this around is add 1 to get rid of that -1. And I get that y is by itself over here at 3/4 x. -6 plus 1 is a -5. So you can see they are the same equation, just in different forms. That point slope form, like I said, is pretty handy. We're not going to test on that in this class. It's just something I wanted to show you. All right, so that's enough on graphing lines for now. Like I said, we'll talk more about parallel and perpendicular lines on Friday. But I want to talk a little bit about parabolas. A parabola comes from an equation of this form. There's something like that. Y equals x squared plus 5x plus 6 will give us a parabola. And a parabola, when we graph it, looks something like this. That kind of U shape. I don't do very good at curving my sides, but you guys get the picture. There are some special features of a parabola that make it easier to graph if we can find. First of all, we have these points right here. You know, on a line, we worry about where it crosses the y-axis. On a parabola, we worry where it crosses the x-axis. And usually, most often, it'll cross it at 2 points. Those 2 points are called roots. So the first thing we find is the roots of the parabola, where it crosses that x-axis. Next is something called an axis of symmetry. The axis of symmetry is basically a point where if you folded the parabola, if I took this piece here, this half of it, and I folded it over, it would land on top of the other side. So it divides it into mirror images of each other. The vertex of the parabola, that point here where it goes from going up on one side to going down on the other side, the vertex is on that axis of symmetry. So from those 3 features, we can often get a good picture of what our graph looks like. So let's give you one here that's a little bit simpler graph. Let's see, let's do -8. So y equals x squared plus 2x minus 8. So the first thing we want to find is to find the roots. The roots occur on the x-axis here. And what we know about those points is the y value is 0. So the roots occur when y equals 0. So we're going to replace y here with 0. Now this next part, some of you may be familiar with, some of you it might be new to you. We are going to take this right side of the equation and we're going to factor it. Factoring means reversing multiplication. If I have 2 times 5 equals 10, if I want to factor the 10, I split it back up into 2 times 5. When we're talking algebraically, with algebraic numbers, we might have x plus 4 times x minus 2. And back in unit 1, we multiplied those out. We did x times x is x squared. X times negative 2 is negative 2x. 4 times x is 4x. 4 times negative 2 is negative 8. And then we combined what we could combine. The x squared is going to stay. We've got negative 2x and positive 4x is positive 2x. And the negative 8. Well, you might have noticed that's what we had right here. So we know at this point that that factors into x plus 4 times x minus 2. It's the same thing. X squared plus 2x minus 8 is equal to x plus 4 times x minus 2. Without doing this here, though, how would I have been able to figure that out? Well, we can see over here that this x squared comes from these first 2 digits. So this is an x squared, so it has to be x times x. So those first 2 digits have to be x and x. The negative 8 here comes from multiplying these last 2 digits, the 4 and the negative 2. So those 2 digits had to multiply to make a negative 8. So either 4 times a negative 2, or negative 4 times positive 2, or negative 1 times a positive 8, or 1 times negative 8. Those are my only choices. How do I know which one to use? Well, that's where I have to try them and multiply them out to see if I get the right center number. I go ahead and I know that when I multiply these two, I'm going to get x squared. And I know that when I multiply these two, I'm going to get negative 8. So I know that those digits work. I have to worry about this center digit. Well, that's going to be from the outside. If I'm looking at FOIL, this is the first, this is the last. What I have left is the outside. X times negative 2 is negative 2x. And the inside, 4 times x is 4x. That's the I. So what I'm worried about is, does the outside and the inside add up to what I need this to be? Negative 2x and positive 4x is positive 2x. So that is correct. So that verifies that this is the correct factoring. So how does that come to my graph? Well, I know that 0 is equal to x plus 4 times x minus 2. And one of the things in our 0 product rule, most people know the 0 product rule to just be anything times 0 equals 0. But a more advanced form of it is, if 2 things multiply to be 0, then either the first one's 0 or the second one's 0, or both. So if x plus 4 times x minus 2 equals 0, that's telling me that either x plus 4 has to equal 0, or x minus 2 has to equal 0. So now we solve, we're going to subtract 4 here. Either x equals -4, or here we would add 2, x equals +2. So what that means on our graph is our roots are at x equals -4, that's right here, and x equals 2, that's right here. So those are our roots. The axis of symmetry, which is the second thing we need to find, is right between the roots. If I average the roots together, I'll have the x-coordinate of the axis of symmetry. -4 plus 2 over 2. -4 plus 2 is a -2 over 2 is -1. So x equals -1 is my axis of symmetry. So here's where x equals -1. That is my axis of symmetry right there. That tells me I know that the vertex is on that axis. So to find the vertex, I know the vertex occurs where x equals -1. So I go back to my original equation. Y equals x squared plus 2x minus 8. And I replace x with -1. Y equals -1 squared plus 2 times -1 minus 8. And now it's just order of operations on the right side there. -1 squared is 1. 2 times -1 is a -2. And minus 8. 1 plus -2 is a -1. -1 minus 8 is -9. So y equals -9 when x is -1. So that tells us the vertex is at x is -1 and y is -9. So that's the point of my vertex. It's my ordered pair. So here we are. X is -1, y is -9. Right there's my vertex. Now that is enough to give us a rough sketch of the parabola. If we wanted to, we could find more points and use this axis of symmetry. Let's say I wanted to find a point somewhere in here. Let's pick x equals 0. If I put 0 in here for x, and I'm kind of running short on time, so I'm going to kind of glance through this. 0 squared plus 2 times 0 is 0, minus 8. If x is 0, then y would have to equal -8. So I can put that point in there. X is 0, y is -8 is right here. Well, because of the axis of symmetry, I know there's a point on the other side of the axis in the exact same spot. It's right there. So finding that one point actually gave me 2 points. And now I can probably sketch in the graph of my parabola. Like that. In the homework posted on Blackboard for you, there are a few problems like this in the worksheets. If you want to do them, it's not going to hurt your grade if you don't do them. I will not test on graphing parabolas with a shortcut. You will have to graph a parabola using a table. So on the test, you will have to, be able to pick values for x, figure out what y has to be, put those points on the graph to make a parabola. Being able to do it this way is just a shortcut. So anyway, in Blackboard, again, posted in course information, there are actually a couple of worksheets. The first one is finding equations from slope and point. If you open that up, that's what we were doing to start off the day. First, I give you the slope and the y-intercept. Write the equation. Y equals mx plus b. Then there's several. I give you a slope and a point that the line goes through. Write the equation from that. And then there's a handful of, if I just give you 2 points that it goes through, find the equation from those 2 points. And then this last one here, it's the middle one here actually, worksheet, graph quadratics, parallel and perpendicular. The parallel and perpendicular part is what we're going to do on Friday, but you can see there are 6 here that are quadratic equations. So you can find the roots to plot those points and draw the parabola. Or if you don't want to do that, since we got kind of cut short on time of looking at that, you can just make a table, pick values for x, and plot them on there. But I would recommend you do at least the first 3 to make sure you understand how to graph those, how to plot those. Okay, that is about all of our time for the day, so I'm going to let you guys go. You guys have a great day, and we'll see you on Friday.